Good morning, everyone. Welcome to Math Mondays. I'm Miss Barnes, and the segment that follows is math for kindergarten through second grade. Hey there, friends. Today, we are going to wrap up our conversations on comparing numbers. While we're working today, we're going to be using base 10 blocks, but we're also going to be using a number line. We made a number line several weeks back, but if you don't have one, that's okay. Find a piece of paper, fold it in half, put a line through the middle, and mark it at 0, 5, and 10. Okay? So today, as we are talking, our objective is I can use reasoning to compare numbers. Now what that means is that you're going to see some problem solving, and we're going to have to use our thinking brains in order to get to the answer. So take a minute now, and let's get ready to learn. All right, here's our first problem. Remember, when we see a word problem, we should read it from start to finish before we try to do any math with it. So let's read this problem from start to finish. 3 friends wrote a number on paper. Paul wrote a number that is greater than Nicole's number and smaller than Tina's number. Nicole's number is 42. Tina's number is 44. What is Paul's number? So that's our first problem today, and you'll see on the right side of the screen that I have the base 10 blocks ready for us if we need them. But before we do that, we need to do a lot of talking about what this problem says. So I'm going to pull out my highlighter tool, and let's go through and read each sentence and decide if we need to do anything math related with that sentence. So let's start from the beginning. 3 friends wrote a number on paper. Does that tell you how we're going to do the math? Does that give you any clue as to what we should calculate or an answer we should find? I don't think so. But what it does tell us is that we're going to have 3 things to compare because we have 3 friends. Okay? So I am going to note that by down here, I'm just going to put 3 lines so that I know I will have 3 numbers at the end. Now let's read the next sentence. Paul wrote a number that is greater than Nicole's number and smaller than Tina's number. And that's where the sentence ends, so that's where we'll stop. But we're actually going to break this sentence down into 2. So we're going to break it down into what's before, change to my highlighter, sorry about that, what's before the word and then what's after the word and. And the reason why we're doing that is because we have 2 pieces of information in this sentence. So let's talk about the first one. The first part says Paul wrote a number that is greater than Nicole's. So we know we have 3 friends. One of them is named Nicole. One of them is named Paul. So now what we have to do is we have to decide where on our lines do these names go. Well, this says Paul wrote a number that is greater than Nicole's number. So we talked last week about the number that is greater being on the right. Keep that in mind as we're working today. The second part of the sentence says that it's smaller than Tina's number. So the third friend's name is Tina. Now we have to decide which order these names go in. So I'd like you to imagine that these names are on a number line. Switch back to black here. So I'm going to make these 3 lines into one number line. Okay? And remember, when we're looking at a number line, the number on the left is always the smallest. So if you think about the number line from 0 to 10, the number line starts at 0 on the left and goes to 10 on the right. So here, we know on a number line that numbers that are smaller are on the left, and numbers that are larger are on the right. So as we're looking back at this sentence, can you tell me the order that these names should go in? Paul wrote a number that is greater than Nicole's number and smaller than Tina's number. What do you think about the order of the names that I have here? Do you think this is how they should be on the number line? I think so, which is great. So now let's talk about the next sentence. The next sentence says, Nicole's number is 42. So with Nicole's number over here, what I'm going to do is mark hers, and I'm going to write 42. Okay. Now we do Tina's. Tina's number is 44. So here's Tina's hash, and her number is 44. So then the question we have to answer is, what is Paul's number? So we're going to write a sentence that says Paul's number is, and I want you to think about the problem that I'm asking you to solve. What is Paul's number? So we know that it's in between 42 and 44. How many numbers are between 42 and 44? That's right, just one. So what is Paul's number? You guessed it. Paul's number is 43. So down here, when we're finishing up our sentence, we just need to write that Paul's number is 43. Great job on that problem. That took a lot of your math brain. So take a quick break, and we're going to move on to problem number 2. All right, are you ready? Here's one for you to try. This one says, Mary has 21 red ribbons. She has 12 yellow ribbons. Does Mary have more red ribbons or yellow ribbons? So we are going to go back and start at the beginning and stop and read, and then try to decide what we're going to do with that sentence. So the first sentence says, Mary has 21 red ribbons. So down here, what I'm going to do is write the number 21. Then it says she has 12 yellow ribbons. We're going to stop there. So now I'm going to write on the right side of my screen the number 12. And the question we have to answer is, does Mary have more red ribbons or yellow ribbons? And so the sentence that will answer that question is, Mary has more blank, because we don't know which color yet, ribbons. And we will use our reasoning in order to solve this problem. So you tell me, should we use a number line here, or should we use base 10 blocks? I agree, it would be easier to use base 10 blocks to compare these two numbers. So on the left side here, we have the number 21. What do you know about that number? How many tens rods should I use, and how many ones cubes should I use? If you said 2 10 rods, you're absolutely correct. So I'm going to drag 2 tens rods over here. And then I just need 1 unit cube. There's my 1 unit cube. Now let's look at 12. And you maybe have already solved this problem. We've been working a couple weeks on this concept. How many tens rods do I need to pull in order to model the number 12? Well, 12 has 1 10 and 2 ones. Now we have to compare. So when I pull my highlighter tool out, you'll see on the left side, 21 has 2 tens and 12 only has 1. So which color ribbon does Mary have more of, red or yellow? That's right, she has more red ribbons. So down here, I'm just going to write, Mary has more red ribbons. And that solves our problem. Great job. We have time for one more question. So let's go ahead and look at the next one. The next question says, Adam writes a number. The number is greater than 50 and less than 54. What numbers could Adam have written? So there's a couple pieces of information here. Adam writes a number. We don't really need that in order to do math. We just need to know that he has a number. But this middle sentence has all the information we need in it. So the first part says the number is greater than 50. The second part of the sentence says and less than 54. So we could do a couple things here in order to compare these quantities. I think this time we should use a number line. And we're going to use a number line because this question is asking for all of the possible answers we could get. What numbers could Adam have written? That means we need all of the possible numbers that he could have written. So on the screen here, I'm going to draw another number line. So here's a not straight number line. And we know that the number is greater than 50. So the number on the left here, we can put as 50 because that's the smallest the number could be. It's definitely greater than 50. And then on the right side, we're going to put the number 54 because that's the largest the number could be. Now your job today is to tell me what numbers are between 50 and 54. So remember, you can share your work with me on Twitter, and I can't wait to see what you have come up with. It was my pleasure having you in class today. Have a great winter break, and I'll see you in January.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.
The desire to create lives within each of us. From Grammy-winning producers and musicians, to NBA stars, to Navy admirals and Medal of Honor recipients, to internationally renowned artists and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
KCPS students, I'm so glad you joined me again for Math Monday. Last week we talked about perimeter, and today we're going to review perimeter but also talk about area. Come on and join me and let's take a look at some problems. Okay, let's review perimeter. Let's take a look at this first blue rectangle. Remember from last week, the perimeter is the total distance around an object, or the sum of all of its sides. Let's take a look at this first problem. I can tell from the information given to me that this rectangle has a total perimeter of 66 inches. That means the total distance around this rectangle is going to be what? 66 inches. Very good. I only know one of the side lengths, 8 inches. But because it's a rectangle, I know that if this side is 8 inches, then so is the corresponding side. This is also 8 inches. So together, 8 plus 8 equals 16. I know that of the 66 inches, these two sides make up 16 of those. Take a minute to think what I should do next. If you are thinking subtraction, that is right. So I'm going to take my 66 total inches and I'm going to subtract what I already know, 16 inches. 6 minus 6 is 0 and 6 minus 1 is 5. That means I have 50 more inches. The sum of these two sides is going to equal 50 inches. Now, if this side equals 8 inches, and so does this side, that means that these two sides are going to be the same amount. What two numbers can I double to get 50? If you don't know, I'll give you a hint. It's the same value as a quarter. If I double a quarter, what do I get? 50 cents, that's right. So that means that I can split 50 into two groups of 25. 25 here and 25 here. Have I found the missing side length? Yes, I have. Now, let's double check just to be sure. If the total perimeter is 66 inches, then that means all of these sides equal 66. Very good. So let's check. 25 plus 25 equals 50. Very good. 50 plus 8 inches equals 58 inches. 58 inches plus another 8 inches equals 66 inches. Excellent. So the answer to the missing side length of this problem is 25 inches. N equals 25 inches. Pat yourselves on the back. That was really good. All right, now let's take a look at the second rectangle. This rectangle has a slightly different shape. It gives us a perimeter of 32 centimeters. So that means that the total distance around this rectangle is 32 centimeters. Now, I'm going to give you a hint. The length of this side is 4 centimeters. So if this side is 4 centimeters, what do I also know? I know the corresponding side. So I have 4 centimeters and 4 centimeters. That gives me a total of 8 centimeters. If the total perimeter is 32 centimeters, I can do the same thing I did in the other problem. 32 minus 8 equals 24 centimeters left. So that means that the sum of these two sides must equal what? That's right, 24 centimeters. So take a second to think. What number can I double that will equal 24? Excellent! 12. I know that I can split 24 into two groups of 12. So that means that these side lengths must be 12 centimeters and 12 centimeters. Now, mathematicians always take their time to check their answer. So while I'm really confident that we got the right answer, I want to take a second to check. I know that the perimeter is 32 centimeters. That means the sum of all these sides must add up to be 32. Let's add them up. 12 plus 4 is 16. 12 plus 4 is also 16. 16 plus 16 equals 32 centimeters. Great job! Now let's talk about area. Area is the amount of square units it takes to cover a figure. Look at the figure I just drew. Can you see the square units in there? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The area of this figure equals 20 units. It takes 20 of these individual units to cover the figure I drew. Remember, when you're finding perimeter, we're talking about the distance around an object. But when we're finding the area, we are talking about the amount of units it takes to cover this entire object. So let's take a look at the purple figure here. I know that this is a square, which means all of these sides are going to be equal. 22 yards is the measure of one side, and I know that that's going to be the measure of every other side, since it is a square. If area is the amount of units needed to cover the figure, I'm going to be finding out how many square yards are needed to are needed to cover this square. I can do that by multiplying the length times the width. So I can multiply 22 by 22 because that is the length and the width. I'm going to give you a second to figure that out. The area of this square figure equals 484 yards squared. You can also write that as square yards. So this shape here has an area of 484 yards squared. So that means that there are 484 tiny square yards covering this entire figure. Now let's take a look at this next shape. This one may be slightly easy for you to multiply. It gives us the area. It says the area is 60 square feet. And we're also given one of the dimensions. We are given the width. So if the area is 60 square feet, and I know that area equals length times width, that means 6 times a number is going to get me 60. What times 6 equals 60? That's right, 10. 6 times 10 equals 60. So that means the length of this figure, the length of this side is equal to 10 feet. And I can check that by multiplying the length times the width. 10 times 6 equals 60. Very good. And that checks out with my area. We have time for one more problem. So let's put what we know about perimeter and area together. Let's take a look. A rectangle has a length of 9 millimeters and an area of 270 square millimeters. What is the width and what is the perimeter? Okay, so let's take a look at what we know. We know that the area is 270. And we also know that the length of this figure is 9 millimeters. If the formula for area equals length times width, I know that 9 times W is going to get me 270. Therefore, I can take 270 and divide it by 9 to get W. Or I can think about multiples. You choose which way you want to find W, and I'm going to give you a minute to think it out. All right, what did you come up with? W equals 80 millimeters. Very good. 9 times 80 equals 270 square millimeters. So the width is 80 millimeters. But we have another question. What is the perimeter? So if I know that W is 80 millimeters, I also know that the corresponding side is going to be equal. And I can also fill in the length of this side, which I know to be 9. What do I have to do to find the perimeter again? That's right, I got to add it all up. So 80 plus 9 equals 89. And the same over here, 80 plus 9 equals 89. I'm going to come down to some open space and add up 89 plus 89 to get my perimeter. 9 plus 9 is 18. 8 plus 8 is 16 plus 1 is 17. The perimeter of this object is 178 millimeters. Excellent job today, guys. Thank you so much for joining me on Math Monday. I hope you learned a lot, and I'll see you next week.
I chose manual because it's challenging and fun, and it can help me with college.
I chose manual because I wanted to get a jump start in my career with culinary arts.
I chose manual to acquire skills I'd use in real life.
I chose manual because I want to be an ER doctor, and being an EMT is my first step.
Kickstart your future today at Manual Career and Technical Center. Manual is open for all 11th and 12th grade students in both Kansas and Missouri. Learn more today at enrollkc.org/manual or call 816-418-5200.
I love Southeast because of the culture, the band program, and restorative justice.
I love Southeast because of the academics, sports, and students.
I love Southeast because of the people, the energy, and the advanced classes.
It's not alike. I love Southeast because the students here at Southeast are full of potential and they believe in achieving anything.
We are Southeast. Southeast. We stand shoulder to shoulder.
Join the Southeast family. Enroll today.
My name is Mary Jo Finger, and this is Math for Middle School. Today what we're going to be talking about is solving equations with one variable. You'll need some paper and pencil to follow along. Okay, let's get ready to learn. When we talk about solving equations in one variable, we're talking about equations that are mathematical statements that consist of an equal symbol between two expressions of the same value. I have 4 different equations here. The 2 on the right are actually complete equations, meaning they don't have any variables. The ones on the right actually contain variables, and those are going to be the ones like we're going to be working with today. But I want you to notice something about the ones on the left. Both of these equations, if we go ahead and solve or simplify the side of the equation that we can work, we actually notice that both of sides of the equations are equal. So 3 plus negative 7 is negative 4, and negative 4 is equal to negative 4, so we call that a true statement. And notice we have minus a negative. Remember from our last conversation that is the same as saying plus a positive number. And negative 2 plus 8 is going to be 6. So 6 does equal 6, so that is also true. So if you come over and look on the right, we have some missing terms. These are called variables. We represent them with the letter X or N most normally. And this is the type of equation that we're going to be working with. Let's take a look at some vocabulary before we get too far. A variable is going to be a term that represents an unknown quantity. Like I said earlier, X and N are going to be your most common. But sometimes in story problems, we're going to write letters that are the beginning letter of the word. Makes it a lot easier for us to remember what that missing variable actually represents. A constant is a term that remains the same. Those are going to be the numbers that don't have a variable attached. They are always going to be 7. They're always going to be negative 2. Those are the 2 examples that I gave you. Inverse operation are mathematical operations that are reverse of each other or undo each other, such as addition and subtraction, or multiplication or division. As you get later on in the school year, you're going to be talking about square roots and powers. Those are going to be opposite or inverse operations. Think of an equation like a teeter-totter. We've all been on teeter-totters in the playground. There's a happy medium where both sides are going to be equal. And that's where you want to keep our equations. If we remove a number from one side, our equation is going to be lopsided, and one side's going to be higher than the other, and it's going to be out of what we call equality. And we need to make sure that all of our equations are in equality at all times. Remember to keep both sides of them balanced. We must do the same thing. So let's take a look at our first one. X plus 8 equals 15. You can already probably think in your head, okay, I already know a number. What plus 8 is going to be 15? Well, that's great, and you can already say that, but sometimes we want to practice our actual steps or show our algebraic thinking. So if we think about, okay, what plus 8 is going to be 15, we're going to subtract 8 from both sides. So when we do that, that creates what we know as a zero pair. And we're going to do the same thing on the other side. So X is going to be equal to 7. Hope that was a number you were thinking of because that was easy. Okay, let's try another one. X minus 3 is going to be 8. I hope you already have a number in your head. Oh, well, that's right. I'm just going to add 3 to 8, and that's going to give me my missing number. Absolutely. And to show that algebraically, we're going to add 3 to both sides. We're going to add 3 to both sides. Remember, we got to keep that equation in balance. When we're thinking about, okay, what can I do? I'm just going to add 8 to add 3 to the other side where 8 is. We can do that. That's perfectly fine, but our equation is out of balance, so we need to think about that equality part. So that's going to be 11 So x is going to equal 11. Let's do one with multiplication. What's the opposite of multiplication? Awesome, it's division. So what we're going to do is we're going to use a fraction bar to represent our division. And so notice our x, it's -5 times x is equal to 35. Well, remember, we're going to undo it. So instead of multiplying times -5, we're going to divide by -5. So we're going to divide by -5, divide by -5. Okay, x is going to equal, yeah, I heard it, -7. Good job. Let's try another one. What's the opposite of division? Right, multiplication. Remember that fraction bar right there? That fraction bar means division. So the opposite of that is going to be multiplication. So I can just come down here and say times 12, or probably the way your math teachers are going to be showing it to you, they're going to stick a dot right here and say times 12, and they're going to do the same thing on the other side. So what's 3 times 12? Awesome, that's 36. So x is going to be 36. So let's talk about when we work with multiple operation equations. So remember, we're going to do the reverse of order of operations for these problems. So order of operation is going to be parentheses. Probably about 6th grade, 7th grade, parentheses really kind of goes out of style because we're having other symbols come in and they represent our grouping symbols. So parentheses, grouping symbols, then we're going to do exponents, then it's multiplication or division working left to right, and then it's addition or subtraction working left to right. But remember, we're undoing these, we're working them in reverse, so we're going to go in reverse. So the first thing we're going to undo is going to be our addition or subtraction. Then we're going to be doing our multiplication, and then we're going to be doing our exponents. Now I'm going to put, not really list parentheses or grouping symbols, because sometimes we're going to have to undo those grouping symbols to start off because we can't actually get to the addition, subtraction, or the other operations. So pay careful attention to the grouping symbols because we may have to do those first. So let's take a look. So if we have 3x minus 9 equals 15. So remember, in our order of operations, last thing we're going to do is addition or subtraction. So that's the first we're going to undo. So notice, and I'll put this in highlighter, is we're going to subtract 9. What's the opposite of subtracting 9? Yes, it's going to be adding 9. So we're going to add 9 to both sides. Remember, this is our teeter-totter. We're trying to keep it in balance. Whatever we do on one side, we have to do to the other, and that's called equality. It's actually called reflection of equality, but we'll get into that in Algebra 1 in high school. So then we're going to come down here. I always like to rewrite everything because that is going to keep my mind going, oh, the next step is, oh, the next step is. So take a break, rewrite your equation. Take some time to let your brain think about what's going on in the equation. It's better to be right than be fast. Accuracy is more important than speed. Speed you come up with as you practice, okay? So notice now we have 3x is equal to 24. Remember 3x, 3 times x, what's the inverse? Oh yeah, that's right, division. So we're going to divide by 3. Remember, whatever number we're multiplying by, we're going to do the reverse. We're going to divide by that same number. So this leaves my x all by itself. And 24 divided by 3 is, yep, that's 6. So our missing term x is actually 6. Let's take a look at another one. So 4x plus 6 is equal to 24. Give you a quick second. What's the last thing in order of operations? Ah, yeah, addition and subtraction. So notice here we have adding 6. What's its opposite? Yep, you got it, subtracting 6. So we're going to subtract 6 on this side. So now we have 4x is equal to, you got it, 16. So remember, we have multiplication here again. The inverse is, you got it, division. So we're going to divide by 4. We're going to divide by 4 on the opposite side. X is now equal to, you got it, 4. Good job. You really are getting the hang of this. Okay, let's throw in some division along with our subtraction. So notice I'm going to highlight for you our subtraction. Remember, this is the last thing in order of operations, which means it's the first thing to get undone. So what is the opposite of minus 3? You got it, plus 3. Remember, keep it in equality. We have to do plus 3 on the other side. Okay, so I'm going to go ahead and write that down as you think. What is 7 plus 3? Yep, it's 10. Now, notice this fraction bar. That fraction really means division. What's the inverse? You got it. Multiply. So we're going to multiply 5 on this side. So x is going to be equal to 50. That concludes our lesson for today. Let's take a quick review. To keep an equation in equality or balanced on both sides, we must treat both sides the same. Remember, a teeter-totter goes up, goes down. We want that great place in the middle where both sides are balanced. To isolate the variable, you're going to do the reverse, known as the inverse operation, until you come up with one side has your variable, the other side has one constant. Remember to keep working on solving equations. Practice makes accuracy, accuracy creates speed. Take time, work through the problems. If you need to create models using the teeter-totter method, go ahead, take the time to do that. It's been my pleasure having you in class today. My name is Mary Jo Fender, and I'll see you next week.
Lincoln Middle. At Lincoln Middle School, students discover their talents and passions, where teachers plant the seeds of lifelong learning.
I am Lincoln Middle.
Where excellence is nurtured. Students develop the skills to be successful in school, career, and beyond.
Je suis Lincoln Middle.
Lincoln Middle is the public school where your child will thrive and grow. Open a world of possibilities. Apply today. Learn more at enrollkc.org/Lincoln Middle.
The desire to create lives within each of us. From Grammy-winning producers and musicians, to NBA stars, to Navy admirals and Medal of Honor recipients, to internationally renowned artists, and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
Hello, my name is Marcelina Lirius and welcome to Math Monday. In this video, we are going to work on sample released items that are aligned to the Algebra 1 standard A1 LQ A1. Determine that linear functions change by equal differences over equal intervals, and recognize situations in this quantity changes at a constant rate per unit interval relative to another. Before we get started, please be ready with your supplies. You will need a pen, paper, and a calculator. So this first item is a multi-select item. So when you encounter problems like this, you are to test all options given, and usually multi-select items have at least 2 correct answers. So this has 6 choices. So we'll test all of these choices. Okay, So which table represent linear functions? So again, when we say linear functions, they change by equal differences over equal intervals. So let's look at the intervals here. Equal intervals, you have 1 and 1. And the differences, let's check if they're equal. Okay, 4 from 3 to 7, 7 to 11, 4 and 4. So our conclusion is this table represents a linear function. Okay, let's look at the second one. So from 1 to 2 over these intervals, do we have equal differences? So you now have the difference here. We move from 1 to 4, you now have 3. We move from 4 to 9. The difference here is 5, and the difference here is 7. Okay. So our conclusion, this table does not represent a linear function. Let's consider the third option. So for letter C, again, if we move from 1 to 2, 2 to 3, 3 to 4, do we have equal differences? Okay, from 3 to 6, you have 3. From 6 to 12, it's 6, and here it's 12. So our conclusion, this does not represent a linear function. Then for letter D, you try this first on your own. Check if this table represents a linear function. Okay, look at the intervals, okay? Again, over equal intervals, will there be an equal difference here or differences? So we have 0.5 and 0.5. Okay, from 2 to 2.5, there is a difference of 0.5. So this is a linear function. Okay. About the last two. I'll give you a moment to try this on your own first. Get your pen, get your notebook. Let's see if we arrive at the same answer. Okay. Again, you have here equal differences. Let's look at the difference. From negative 50, if you move to negative 45, there is a 5-unit difference. 5 and 5. Okay, you can also visualize this as if you are on the number line, how far do you move from negative 50 to negative 45? Remember, if you have negative numbers, you're moving actually here from negative 45, you're moving to the right. So you move 5 steps to the right. And this is representing a linear function. Okay. For letter F, what do you think? Just by looking at the numbers on the Y column, do we have equal differences? This is 19 and this one is 37. Could you double check? Okay, now later on, you might discover that this will represent a different type of function. Okay, if you have 1, 8, 27, 64. Okay, this is not a linear function. I'm sorry. This is not a linear function, so we cross this out. So going back, of the 6 choices we arrived at, okay, you have letter E, letter D, and letter A. So there were 3 correct answers, letter A, letter D, was it D? And the last one was E. So again, for multi-select, careful, you have to test all the options. There are at least 2 correct answers. Okay. Ready? So in the next item, we are given a table with points that are on the graph of a linear function. So this is already predefined that this table represents a linear function. So we are asked which function represents the same relationship. So we are asked which of these equations here would represent the table of values. So we have here h of x, and remember our function notation y is equal to f of x, or in this case our function name is h. So we can replace y with h of x, or h of x with y. So going back, you have the equation y equals mx plus b. So this is the slope-intercept form of the line. So we have points here, the ordered pairs x and y, So we have the ordered pair for x, negative 7.5 and 12, negative 3.5 and 0, negative 1, 7.5, and so on. So we can have, actually, these values, we can take a point, x and y, any point on the table. And our goal here first is to find our slope. So if you remember the slope m, we have the formula m equals y sub 2 minus y sub 1, or the difference in y over x of 2 minus x of 1. So if we take a point on the table, so we can take one ordered pair. So if this is our x of 1, if we have negative 3.5 as our x, the y value is 0. So we have an ordered pair x of 1, y of 1. And we can take another pair, which is our x is negative 1 and y is negative 7.5. So with these values, we're going to substitute this and find the slope, m. So m equals, this could be our x of 1, y sub 1, and this is our x of 2, y sub 2. Okay, so start. Y sub 2 is negative 7.5, okay, minus y sub 1, which is 0, over our x of 2, you have negative 1 minus negative 3.5. I'll stop here. We're just substituting the values. So m here, if we simplify, gives us negative 7.5 over, this becomes, this becomes plus. So if we simplify minus 1 plus 3.5, this will give us 2.5. So the value for m here is, get your calculators, this is negative 3. So now we have the value of m. Our next step, after finding the value of m, is to find the value of b. We need our b and m. Okay, so our b now is, we have y equals mx plus b. So we already have b, and to solve, we can substitute or take any value for x and y here. So I will choose a more convenient point, which is the negative 3.1, 3.5 and 0 as my x and y. Okay, substituting, y will be 0. We already have our m, which is negative 3, which we found earlier. And my x is, from this point here, I will have my x is 3.5 negative plus b, which is unknown. Okay, simplifying, negative, negative, here will be positive. So this will be positive 10.5 plus b equals 0. Then solving for b, subtract negative 10.5 from both sides, so our B is negative 10.5. Okay, so we now have our values for M and B. So of these equations, let's look at this. Y equals mx plus b. So if you're taking the test, just look at the, you can eliminate already. We already have negative 3 as our slope, so this is eliminated. Okay, this is eliminated. Even without solving for b, we are already able to eliminate these 3 choices. So the first choice here is actually the correct answer, and it represents the same relationship as the table of values provided. Okay, so M is negative 3 and B is negative 10.5. Okay, give you time to process. So that concludes our session for today, and I hope to see you next week.
I am Lincoln Middle. At Lincoln Middle School, students discover their talents and passions, where teachers plant the seeds of lifelong learning.
I am Lincoln Middle.
Where excellence is nurtured. Students develop the skills to be successful in school, career, and beyond.
Je suis Lincoln Middle.
Lincoln Middle is the public school where your child will thrive and grow. Open a world of possibilities. Apply today. Learn more at enrollkc.org/Lincoln Middle.